Hello students, in the last class we have seen about the introduction of the uniform plane wave. Now today we will see the wave propagation in the free space. So we consider the electromagnetic wave propagating through the free space. Now for a free space, sigma is 0. So consider that electric field in the wave is in x direction only, while the magnetic field is in the y direction only. Both the fields, that is electric field and magnetic field, do not vary with x and y but only vary with respect to z. So therefore the field also vary with time as a wave propagates in a free space. Right? So basically the plane waves means electric field vector E and magnetic field vector H lie in the same plane. Also the different planes along the direction consisting of E and H vectors are parallel to each other along the direction of propagation of the wave. So here E and H are mutually perpendicular to each other. Electromagnetic waves are also called as transverse electromagnetic waves. As the wave travels in z direction, it is clear that the direction of electromagnetic wave, that is uniform plane wave, is perpendicular or orthogonal to the plane consisting the E and H field vectors. So you can see in this slide that when considering the electromagnetic waves in the free space, we note that medium is sourceless, that is rho v or j is equal to 0. So under these conditions, what happens? The Maxwell equations may be written in terms of E and H only as del cross H is equal to epsilon naught dou E by dou T. Del cross E is equal to minus mu naught dou H by dou T, or del dot E is equal to 0, del dot H is equal to 0. These are the Maxwell equations. All four are the Maxwell equations, where in a free space what happens? Rho v and j becomes equal to 0. So using the equation 2, what we can do is we note that with these restrictions the curl of E reduces to a single term, that is del cross E is equal to dou Ex divided by dou Z Ay. That is we can get only the single term, that is nothing but minus mu naught dou H by dou T, or minus mu naught dou Hy by dou T Ay. So that is what only this equation is reduced to only one of the form, that is along the x form. Therefore now using y directed magnetic field and the fact that it varies only in the z, so simplifies the equation 1 to read. So del cross H is equal to dou Hy divided by dou Z Ax. There is nothing but equal to epsilon naught dou E by dou T is equal to epsilon naught dou Ex by dou T Ax. So this is equation number 6. Means what? Equation 1 and 2 are simplified in terms of only x and y directions, right? So that is x and y directions, because these fields are along only E field is along x direction and y field is along y direction. Magnetic field is along y direction. So therefore these two are equation. These are the equation number 5 and 6, which shows the E directed field in x direction and y magnetic field in the y direction. Next, equation 5 and 6 can be more succinctly written. That is what? Dou Ex by dou Z is equal to mu naught dou Hy by dou T. That is equation number 7, right? And dou Hy by dou Z is equal to minus epsilon naught dou Ex divided by dou T. So this is what you can write the equation after simplifying the equation. Now specifically we differentiate equation 7 with respect to z again. So obtaining dou Ex divided by dou Z square is equal to mu naught dou square Hy divided by dou T dou Z. And also equation 8 can be differentiated with respect to T. So dou square Hy divided by dou Z dou T is equal to epsilon naught minus epsilon naught dou square Ex divided by dou t square. So these are the two equations after differentiating equation number 7 and 8. Now substituting the 10 in 9, so we will get the results, that is dou square Ex divided by dou z square is equal to epsilon naught mu naught dou square Ex divided by dou t square. This is the equation for what wave propagation for electric field. So similarly you can have the equation for wave propagation in terms of magnetic field, that is dou square hx divided by dou z square is nothing but equal to mu naught epsilon naught dou square hy divided by dou t square. So these are the what equations of uniform waves propagating in the free space. So this was about the two equations. One, the equation is in the form of electric field, that is in the x direction, and one more is in the magnetic field in the y direction. Thank you.